Okay, I would like to go over just some of number one here. First, I'd like to go over number one. I'm not going to go over the back, but I'll give you the answers at the back so that you can check. Okay, so here we've got a diverging lens. It's got a focal length of 9 centimeters, and the object is placed 3 centimeters in front of the lens. Here's my object. All right. What is the distance of the image from the lens? Pardon me. So what do we know here? We know the focal length is 9 centimeters, but we also know this is the diverging lens, so it's really negative 9 centimeters. We know the distance to the object is 3 centimeters, and I'm looking for the distance to the image. So I'll start by using our, beg your pardon, starting by using our fundamental lens equation here. 1 over dO plus 1 over di equals 1 over f. So that's 1 over 3 plus 1 over di equals 1 over negative 9. So 1 over di is negative 1/9 minus 1/3. If I put this with least common, or with common denominators, it's going to be 1/9 minus 3/9, which equals negative 4/9. Okay, so now I've got 1 over di equals negative 4/9. How do I solve that? Well, I can cross multiply, right? And if I cross multiply, I see that negative 4 di equals 9. So di equals negative 9/4, which is the same as 2.25, right? So the di is 2.25 centimeters. Okay, to find the magnification of the image, remember that you can use any two parts of this equation you want. So I'm just going to set up m equals negative di over do. And I'm going to ignore this middle part. Since there's two equal signs, you just set any two parts of that equation equal to each other. Okay, so magnification is negative. Ooh, I messed something up here. This is a negative 2, I think, right? Because negative 9/4. So this should be negative di, which is negative 2.25, divided by do, which is 3. Calculate it out real quick. So negatives cancel out, and I'm left with a magnification of 0.75. Is this image real or virtual? Well, di is negative. That probably means it's virtual. Hope you can't see that. Is it upright or inverted? Now, this is something that we haven't really talked about so much. Technically, whether it's upright or inverted, is based upon the sign of HI. But there's a trick you can do using this, right? We can tell that, well, whenever an image is virtual, well, let me explain that. The idea here is that whenever an image is virtual, it's going to be upright. Whenever an image is real, it's going to be inverted. So this is, since it's a virtual image, it's going to be upright. So I can say upright because image is virtual. There are another few things that can help you with this, right? If we really wanted to figure it out, right, we could say, okay, the magnification is HI over HO. We know that HO is always positive, so HI is going to be positive as well, which is going to make it upright, right? The other way you can say it is there's a thing, magnification always works this way. Whenever magnification is positive, we're always going to be virtual and upright. And whenever magnification is negative, we're always going to be real and inverted. By the way, this is an upright, however you think about it, this is an upright I'm going to have the sub pause the video and give you about 10 minutes to work on what's on the back. So if we could pause the video. And now that we've unpaused the video, I'm going to turn my paper over so that you can see the answers and you can check your answers. So these are the answers to the back. So I'm going to expect the work, to see the work for having gotten these answers. If you can't get the answers, go ahead and talk to a partner, see if you can figure it out with a partner. And before you leave today, go ahead and turn this paper in so that I can look at how we're doing.